Hello guys, my name is Diego Pacheco and this is a Java video. So basically today we're gonna see some techniques how we can build abstractions, how we can deal with problems using object orientation. Specifically, I'm gonna be going through the iterator pattern and some different flavors and understand a bit more about some trade-offs. So I hope you guys like it. So let's get started. So here I have my idea. So let's say we want to write an algorithm that filters only vowels from a string. So you have consonants and vowels, and let's say you only want to get the vowels, right? So let's say we write some code in more like a functional style, just a function, right? So that would look like something more or less like this, all right? Where let's say I have this method called getVowels where I'm gonna pass a string and I'm gonna return a list of characters with the vowels there. The vowels is a finite universe, so it's A, E, I, O, I-E actually, O-U. There are 5 vowels. So basically what I'm doing here is I am calling the method getVowels and passing this word. ABC is easiest 1, 2, 3 dots. Then this will return to me as a list of characters, and then I can call for each and print it, right? So first of all, I always like to run things and see them working before we understand deeply about the code. So you can see it works. I have 1, 2, 3, 4, 5, 6, 7, 8 vowels, so that's about right. Okay, that's awesome. So the code works. Now let's understand the algorithm. So the algorithm I made this way. So I create like a position, which are going to start with 0, and then I create an array list of character that will be my result. I also have all possible vowels in lowercase, A, I, E, E, I, E actually. I keep switching that Portuguese thing, O and U. Then what I'm doing is, while the position is smaller than the length of the world, right? And if that's the case, well, then I'm gonna do some computation. Then what I'm gonna do is, okay, I wanna know if the vowels, I have all the possible vowels, if they contain the word, the character at the current position of the word. Right, so first time I'm gonna ask for A, then B, then C, then space, then I, then S, then E, then A, and so on and on. And if that's true, it means we're dealing with a vowel. So if we're dealing with a vowel, I want to add that word to my result, and I want to move forward, all right? And then at some point, I'm gonna add the end of the word, and then I'm gonna return the result, all right? So that code works. But now let's say what happens if I want to do this vowel by vowel. Like I don't want to do it all at once. Let's say this is a big string. Let's say this is a sort of 2 gigabyte string, and I might not need to go through all the vowels. So I would like to do this slowly, like give me one vowel at a time. Or imagine I want to do this lazy, right? So I don't actually want to run all the computation. I want to really just get one vowel at a time, more in like in a streamed way. Well, here in this way, it will be a bit harder, right? Because we need to deal with a state. So we need to have some sort of abstraction that abstract state and allow you to do that. And the iterator is a good way we can express both early loading or lazy loading. So let's get into some different flavors, right? So how we can do it, and the algorithm is gonna be it's gonna change slightly, but let's do this, right? So so I have my first implementation of the iterator here, right? This is a vowels iterator. So I implement iterator. So when I implement Java Util iterator, and also I'm saying this iterator of character, I need to provide implementation of two methods. I need to implement hasNext and next. So for hasNext, I tell, do I have an next character, right? So basically, do I have more things to do, right? So one simple implementation I have here is just, so the iterator needs to keep state. So this is a really stateful class, right? So I have the current position where I am analyzing, and if that position is still lower than the whole length of the world, then there's some work to do. Otherwise, we are done, all right? So that's kind of my hasNext implementation. There's some issues here, but we covered it later on. And then we also need to implement next, where I get the next character. In this case, the next vowel, all right? So here, as you can see, I also have an array list with all possible vowels. I have a string where I'm gonna capture the word that needs to be analyzed. So I have a constructor for the vowels iterator where I receive that word. One cool thing here, I can do validations on the constructor, right? So let's say if you pass null or you pass empty, there's nothing to iterate, so I'm gonna throw you an exception. And if you're not send me null or empty, then what I'm gonna do is I'm gonna make the word in lowercase, so I don't need to check for upper and lowercase all the times. So that's a constructor. So let's go through the next method implementation, right? So here, what I'm gonna do is, while the position is smaller than the length of the word, I'm gonna check if the current position contains on the list of the vowel. If that's the case, we are dealing with a vowel. Then I'm gonna return the vowel and I'm gonna increase the position, all right? Otherwise, if we are dealing with a consonant, I just keep going. So this works, all right? And this is gonna be lazy by default, because when you call the constructor, there's no computation going on, right? However, there are a problem here, which is, okay, great, we have laziness, but if I try to call next, I might not get a vowel, and hasNext might say me true, right? Because it might say, yes, there is next element, but I actually saying there are more positions that I can analyze, but not necessarily there are next vowels, all right? So hasNext, I could be breaking the contract somehow, not like the type contract, but the runtime expectation, right? It's still going to be returning a boolean, but it might be not true. And also for next, I might be returning null, as you can see here. So this implementation is good because we can abstract and contain state. Pretty much iterators are fours on asteroids, so we are wrapping the state around that object. They are stateful. It's good here that we are lazy, but sometimes we break the contract. hasNext sometimes tells that's an X and maybe that you got a null. All right, I would say most of times it could be right. All right, you're gonna get an X vowel. But it could be the case that at least one false positive you're gonna get at the end of the word, right? So that's the problem of this implementation. So let's look another implementation. All right, I did another one where I'm calling vowels iterator v2. So this is like in opposite direction. I'm doing like early loading. All right, it has an advantage, but also has some issues. So let's go through the implementation. So I have some word, which is the word you want us to analyze. I have the list of vowels. And now you can see I have an iterator here of character. It's just my result iterator. So what I'm doing on the constructor here, besides of the same validations as vowels iterator v1, we saw it, I'm also doing the computation here. So, going through the whole string, and I'm adding the result, all the possible vowels that are there on this list. And then at the end, I'm getting the iterator of this list. Then my hasNext and next implementation is much cleaner, because now hasNext always gonna be correct, not only syntactically, but semantically. So if I'm returning there is a next element, because really there is, and next, will never return null anymore, right? So let me run the previous algorithm, which is lazy loading, but has this problem of returning null. All right, as you can see here at the end, we got null. All right, but it works. And now, let me run the second implementation, where this is not lazy loading, this is early loading. All right, but the constructs of has next and next are preserved, so it's better on that sense. Here, as you can see, we don't return null, all right, and we are doing things very precisely. But, all right, we are doing early loading. But what happens if we want to preserve has next and next, but be lazy loading? There is a way we can do that. Yes, there is a way. It's not perfect, but we can do it. So basically, you want to make the first computation pays the price, all right? So let's go here. And for instance, just before I go to the final implementation, right? So let's say right here. So one thing you could do is, okay, so if we move the computation outside of the constructor and move to has next, for instance, well, the issue is, if we do that, right, is that has next shouldn't be moving towards on the data structure. You shouldn't be doing computations. You should be just telling the state, all right? And the issue is, if you keep calling has next, when you call next, you might not be able to get any result. So it will be much worse and really bad if we move the computation to has next. If we move the computation to next, well, that's the previous implementation, all right, with lazy loading, but then you have that issue that sometimes you might be getting null. So can we do better? Yes, we can. So that's like the final implementation. So here we have a lazy loading iterator that not breaks semantically the has next and next. So let's see what is the difference. Well, okay. So basically I have the word here, which is passed through me. I have the list of files. I still have the result iterator, but now I have a Boolean saying, okay, is this the first call we are doing? And by default it's true, all right? So then the constructor, again, we don't do anything special, we just capture the word. And now there's a method, all right? This code was on the constructor before, called initialize, where we are doing the algorithm, right? We are doing like the whole algorithm. And here, the trick is like this. So the first time, you call has next or next, no matter which one you call, we're gonna check. So is this the first call? First time you call has next or next, it will be the first call. And then initialize is going to be called. And then we're going to pre-compute all the vowels, all right? And then with that in mind, we're going to mark it to false. So next time you call has next, we're just going to call has next from the result iterator. And the same thing for next. The first time, if you call next before has next, you're going to trigger the first call. We're going to initialize the computation, but then we would never do that again, all right? Doing that, all right, will allow us to make this also lazy, and now has next and next, they always going to work as we expect. The trade-off here is like we are pushing all the heavy lifting to the first operation, right? So the first has next or the first next actually gonna be more expensive than the other ones, and the other ones it's gonna be much more cheaper. So somebody needs to pay the price. So if we look for more towards like functional implementation, where you have a function, every time you call a function, you have the same cost, right? So you are doing the same algorithm. With the iterator, like on my first implementation, we can do lazy loading, but then, sometimes next gonna return no, and sometimes has next, we're gonna give you false positives, right? So it's kind of a breaking the contract of the iterator. If you go to my V2, we don't break has next and next contract, but then we have some early loading. So when you construct the object, that's where you're gonna pay the price, right? So that's where you're gonna have the computation. Or on V3, the pay is not paid on the constructor, but when you do the first actual call to next and has next, because if you're calling these methods, probably right now is the time where you're really doing some real work, so it looks a bit more fair to pay the price. So let me just run here so you can see that it works and we have exactly the same results. So that's it for today. I just want to show some trade-offs and say that, you know, state management is not easy. There's all these different trade-offs between being lazy and being early, you know, and being able to attend and be strict implementing the iterator construct, and that's also something, you know, you kind of want to do. So that's it for today. I hope you like it. See you next time. Cheers.